Who is wowing? Get a wow, didn't say anything. 4 p.m. Friday, so I guess everybody is quite tired. I think this is a presentation that is quite content heavy. I will try to do my best to leave some ideas with you. If you can leave this room with a couple of concepts, that will be a major win. And happy to take questions at any point. Just raise your hand, yell at me if I can see you. You don't need to wait until the end for it. How many of you can define what a data product is? Can I see some hands? Oh, a brave person over there, another one over there. Let's briefly say that is when you deal with data in such a way, you treat it as a first-class citizen that it becomes just a product. Just as we have APIs as a product, we can have data as a product. And we can really have a full life cycle and deal with it in a really good way. So we'll try to help you understand our journey. It hasn't been pain-free. I live in Auckland. I've been working for many companies in New Zealand, and I met the person that ended up hiring me at Palmerston North, the current head of digital. And we're trying to do data and AI stuff, but it's a small council, millions of problems and issues to solve that ended up doing a bit of everything. Being a serverless session, we can keep it really, really, really simple. And maybe Michael will slap me. I don't know him, but I'm pretty sure we haven't followed some of his advice. Well, I think we're quite proud to say no VMs, no EC2 instances, completely serverless. Fingers crossed that we stay that way. We'll quickly introduce you to what we're trying to achieve, and then we'll tell you the story of what is going well, what is not going so well, and leave you with a few pointers so you can take home. And I hope that on Monday you can start convincing some people at work. For many years in my career, I've been saying that the line between operational systems and analytical systems is very, very thin. It's becoming thinner and blurrier, and it's really hard to distinguish now. So I imagine that this picture is quite familiar for many of you. Well, you can see a lot of effort and investment and architecture on the operational systems, many software that we use, and then a team that does some magic, pulls a few things together overnight and pushes data into another place, different set of skills, different set of platforms. Is that familiar to you? Yeah, for those that won't see that familiar, say, hey! And thank you to Copilot for generating that picture for the pilot. So if we stay on AI, even ChatGPT agrees that, yes, the lines are getting blurrier, and if we know that ChatGPT has been trained based on the internet, so that should be a general opinion. So it kind of enforces that idea, or not. Because I also ask, what happens with a data lake? The last sentence is generally true. Most people think a data lake is where data goes to die. And also thanks to, it may be a dog, I don't know. But I put that one because my first goal when I went to Palmerston North was to do analytics. So the data lake was my first thing. And thankfully, there were a lot of integration issues. So I ended up helping there, and that was the main thing that has put all this stuff in place. I'll walk you through that as quickly as we can. So in contrast to the view where you have operational and analytical, these very disparate words, let's try to put it together. Kind of CAP architecture, kind of a data mesh approach. Everything as integrated as we can within the same environment. And we're trying to respect those 4 principles there that a data mesh suggests you should have. So we are really careful with data, which most people in a local council isn't. We want people to have a very easy life and try to find information by themselves. And of course, governance is almost not present. Once I'm given access to a database, I can see finance, HR, telemetry from devices out in the blue. So I can do whatever I want. And data mesh suggests that the main thing you should do is distribute the effort, the power, the ownership of all this data that is a product into the different domain businesses or business domains. A small company like Palmerston North cannot handle that, so that one's a little bit at the bottom for us, but we want to get there. This is what a data product looks like, according to Confluence documentation. All we need to highlight here is, you can see that one on the far right is crossing the boundary, is making that accessible to somebody. So just trying to insist that idea of a product for you, something that you can pick up on the, what we call a data supermarket. You go there, you find on the shelf You can see the description. You say you like it. I'm going to try this product, and I hope it serves me well. And the anti-corruption layer is there to make sure that it can absorb impacts of things changing way on the left-hand side, and ideally, these changes are not reflected on the shelf of your data supermarket. Consumers can still consume in the same way without seeing how things change behind the scenes. And this also diagram stolen from Confluent. The only thing meaningful to highlight is sometimes when you consume data, you don't always do it in the same way. You need a lot of data from an S3, for example, bucket, or you want to consume, do lookups, and you need some kind of database, relational, NoSQL, whatever, or you're happy consuming from an event stream. So different ways of consuming the same product, originating in the same place, is exposed to people, just different use cases that can be handled. Up to this point, any questions? Happy with that data product definition? We take data from somewhere, we try to massage it, clean it up, make it available so people is proud of our work, and we make their lives as simple as we can. Now comes the meaty part. So I hope you're ready for all this set of about 40 slides. Streaming. So I was talking to a colleague outside, and streaming is a thing that we hate or we love, depending who you're talking to. And honestly, I couldn't care less about the real timeliness of the streaming solution. The power is so much more than just something going very quickly from one end to another one, traveling a data superhighway. We started on this journey at the end of 2022. We subscribed to our first cloud provider in December, and 6 months later, we're in production. So you can see that the path was fast, a lot of intention and purpose. And since then, we have grown all this platform quite a bit. Our first thing was the Kafka cluster. And in contrast to previous places that I worked on, we don't pay people to handle a Kafka cluster that is barely maintained. We just pay a company. In our case, we are partnering with Confluent Cloud, and that's why we have primarily this data superhighway. We use schema registry, if you know what that is about, to make sure that these data products are properly versioned and everybody understands what's inside them. That's not a surprise. And you can configure the Kafka cluster for different purposes. We have gone for what is called durability, making sure that every byte you put into, it stays in there, cannot disappear. You can go for low latency, that maybe was something that Michael was looking after, or high throughput. That's not of interest for a council that is happy to see data flowing through after a month from one people's desk to another one's desk. So waiting for data to flow through a couple of seconds is okay. The main output of our data product is a public stream or a public topic. We just put the name public, not because it's public data and anybody in the world can consume it. It's because we're happy for anybody in the council accessing that data. It's so good quality, it's so well described that go and suit yourself. It's going to make you happy. And I keep forgetting that I need to click for this task continues. It's full-blown. This is something that draws a lot of eyes. People don't really get it. Certainly not making too many friends. Some of them, but some of them are really against the idea. It's very different. You're not seeing a single record in our Kafka public stream. You're seeing a full invoice object, for example. The headers, the customer details, the shipping address, the line items, the product, the discounts, the payment methods, the due dates. Everything you can see in the piece of paper that is an invoice, you can see it on that public stream. So once you consume one message, you're pretty much done. You don't need to do any lookups into any APIs to enrich that data. You got that one, and it should fulfill most of your needs. We do have something that is very, very also unusual, infinite retention. So we remember forever. That, along with log compaction, if you don't know what log compaction in Kafka is, it's just the ability to ensure that they always maintain the latest state of an object. So invoice one may be changing over time. You always, in this case, will maintain the latest state of invoice one, not all of the previous states. And that has to do with annoying things like GDPR, all these regulations, that you can't really save everything forever because then you get punished. And there's something that is quite tricky, and this freaks out people even more. I have heard many companies an architecture principle called evolutionary architecture. And every time I hear that from an enterprise architect, I hope there's no EAs in the room because I usually don't make good friends with them. I challenge them. how do you ensure architecture can evolve? And I don't know the answer, but I know that this stuff helps with that. There's many use cases, Airbnb, Uber, big companies that have said, our databases were flaky, so I'm going to tear them down, create them back from scratch, empty, replay our topics in Kafka, and repopulate, rehydrate that database. And nothing happened. Let's move on. So you can clearly have that ability to evolve and continue and try new things. It's not the only thing you need, but it helps. We have what we call private streams, where data goes, it lands over there, coming from a source system. We call it frictionless ingestion. It's not our term, really. And it hits a really, really, really important milestone. Once we save some bytes into these topics in Kafka, that's it. Most of the effort goes there. The rest is very easy. So getting to that point is a big milestone. Real timeliness or not, or near, but nobody really cares, not in council. And the thing is that any changes happening in source systems can be handled at that stage. They usually heal themselves. Most issues we don't even pay attention to. We see alarms popping up, we wait a couple of minutes, the alarm goes away, cool, nothing to do. Every now and then we have a really hard problem because some application provider decided to break things in really big ways. And we try to keep these applications as simple as possible, as dumb as possible, so the first premise is true, is frictionless ingestion. And if you're doing streams, if you're moving data across topics, of course you process the data using stream processing. You don't do Spark jobs, or you don't take the data out of Kafka to then put it again back into Kafka a few hours later. And for this, we use a different set of technologies. No more batches. That's not cool these days, don't use it. A lot of changes happen there. We transform data into a data model that we have in data dictionary, so everybody can understand exactly what's in there. We enrich, we combine streams into multiple things, producing that really big object in the public stream. We clean ugly stuff, we report data quality, and we have a lot of metadata. Every record has a specific metadata object detailing what's going through, so really good quality, really good governance, and we can track things across the way. For example, there we save correlation IDs. So we can track the entire journey of one object all across our platforms with that single correlation ID. So that's what a data product looks like in our world. And that's the data we expose. For those familiar with event sourcing idea has been like for 15 years or so, popularized by Martin Fowler. Really good idea. It doesn't really fulfill all use cases, but we're trying to respect some of that. And the one on the left is the one that will have, again, people getting quite upset with it, because they start to say, so you're telling me that database is no longer the source of truth? And I say, yeah, exactly. And then they turn around and go, because they don't like it. But that is the truth. The thing you can really trust, that is immutable, as you can read there, that you can replay, that is infinite, is the event log. Is that topic that contains every single thing that has been happening to that data across its life cycle. So we're not there because event sources means that the first thing you do is you put data in a topic, not in a database, because nobody does that, except in very specific applications. We're not really doing event sourcing, but we're getting close to it. Good so far? So now that we have that highway with data that we put into it, and we really massage it so it looks really cool and people can use it, then we're going to talk to the right-hand side of it. And feel free to stop me. We'll try to share some use cases here, and you can see the value of having this information in play. And I will see, this is a serverless conference, so we'll try to detail all the serverless tools that we're using. The first one is that we talk to many data lake-related people, and they say, yes, of course, we're going to do CDC, we're going to connect your databases and pump data into the raw layer of the lake, and then have some processing stages and put it to a staging area, and then do more processing and put it in the curated layer, and then it's available, and by then we have spent thousands of dollars in Spark jobs and a lot of compute for really small things that we're moving across. So I said, no, we don't do that. We just put data in the lake. We don't process it. It's just an S3 bucket. With a few more things on top of it, of course, but the data is not being processed. It's curated already in Kafka. It goes as it is, exactly the same structure, into our data lake. So once you understand the structure of our objects, thanks to our data dictionary, you understand what it looks like on the public topic, you understand what it looks like on the data lake, and also through other mechanisms. And from there, we offer things like Athena, Redshift, and SageMaker to do stuff with this information. More stuff from Amazon. Then we need to do a lot of integrations, and because we play on the New Zealand government landscape, we usually have providers from New Zealand, which are not fantastic. We don't play with the best applications out there. These are mostly built by New Zealand companies, so their APIs are flaky. You can't expect things like strong concurrency control, or good webhooks in place, or good APIs. Is a small company in the south of Queensland or something that builds .control application, and we use it. I don't know why you're laughing, but I haven't been laughing all these years, man. So that's typical. We have Lambda functions acting as consumers, picking up from Kafka, reacting to events coming through, and then talking to APIs so data can be put in sync with another system. Yeah, typical integration, nothing special. All we need to know is what that data looks like in the public stream. And it's very easy to enable teams and partners to help us do that. They need to understand the structure of the public stream. They need to understand the API, which is quite easy these days. One Lambda function. Of course, we need stuff happens. So we have really strong observability and alarms in place so we know when stuff happens. Because streaming is picture leaves on a river flowing through and say, oh, there's a problem, it's gone. Ooh. It's gone. It's not a database, you can take a snapshot. Oh, there's another, it's gone again. So you really need to have really strong metadata and observability to understand what's going on your entire pipeline. And you might have heard the term a poison message. Sometimes when you're consuming from Kafka, unlike the queue that Mike was describing, in a queue like in a bank, you get into there, the cashier picks you up. Oh man, I need like 20 more minutes. The cashier picks you up, and then you go away. But in a topic, you stay in the bank. You never leave the bank. That's the analogy here. So when you have a problematic message in a topic, it becomes a poison message because you cannot continue. It's like having a really angry client that doesn't want to leave the bank, then you cannot pick up anybody else from the queue. And idempotency have to be something you can accept. Your systems need to be able to adapt and hold or handle idempotency very well. Obviously, I need to hurry up. Another aspect is we call distributed databases. We read from Kafka, we save it locally, and then we're able to receive requests from an API gateway. And the data that we write into these databases is prepared for good query performance, like what you will do with Cassandra, saving data in its collections that are only prepared for really good query performance, not trying to adapt your queries to what's inside of the database. And then, a bit to our shame, we have an ArcGIS platform, like every council does. ArcGIS is really important for all councils, but it's the only thing that we have running on premise, so that's a server for you. These people open their eyes when they say, oh, so we can update our maps in real time, so if somebody lodges a request over there, or a new registration happens over there, and yeah, you can have it there, and people doesn't have to wait anymore until the next day or so to see it happening. We hope that thing moves into the cloud at least. It may continue to be an instance and ruin a picture and become the first EC2 instance, but it is what it is. And to further make data lake people annoyed, we expand the data lake to the left, and not only we replicate public streams, which is the formatted cool data that we want to expose to everybody, but we also replicate private data, so the one that we obtain exactly as it was from the source system. Really important to have. But there's no P, there's no processing in between. And that freaks out everybody. The data lake just becomes a place where data just sits there. It's not being processed because it's being processed elsewhere in real time. And the last bit from the publishers, and we'll try to speed up here. So we have that data highway. We have the consumers benefiting from that single structure. Now the effort is into putting data into that private stream. And I will just highlight a couple of minimal things here. There's a lot to say really about these diagrams using many Amazon solutions. But basically, most of the systems that we play with don't have things like webhooks. We have to constantly pull them and keep annoying them, telling them, do you have something new for me? When that happens, we are very delicate how we treat that data in a very simple way without trying to over-engineer the solution. And there's a couple of things there like Dynamo to maintain state, SQS to help us recover under situations that happen all the time, and a couple of Lambda functions, right? All of this implies that we can self-heal. Again, we have a lot of integration in place, a small team of 4 people, nobody on call, we don't work on weekends, we don't work at night. Usually, all problems go away by themselves, except when somebody makes something really bad on the far left, that SaaS application, they change something really bad and we don't notice. We have one partner that doesn't do versioning on API, so suddenly they put breaking changes without versioning, and there we go. And migrations, I have always insisted with the idea of don't do migrations, don't recreate an environment that you pull data from that software as a service application all the way into the private topic. Just let it go through. So for us, it's really simple. We go into Dynamo where we maintain this ingestion process state, and we say, forget about everything, start from the beginning, and it's just pulling data from the beginning of time from that SaaS application. A couple of hours or days later, it finishes, but it's a good way to test all of this stuff, make all the data go through exactly the same mechanism. We don't have to build things twice. For when we have webhooks, we're ready for it. Doesn't happen yet. Not even we use big applications like ServiceNow, they don't have webhooks. So yeah, this SQS part will become somewhat optional by then. And when we handle big files that contain a lot of records in them, we also strip them out, and we treat every single line of those files as an individual event and push it into this private stream. No need to deal with them any differently. Ugly integrations, yeah. Unfortunately, in government, it's such a common practice. And we need further metadata details and also some delivery guarantees across the entire pipeline to ensure that every single line on that file made its way through the pipeline and it's not getting lost. And finally, something we're getting ready for, it's coming hopefully this year. We have a lot of stuff on IoT in the council on-prem, so we're taking it into the cloud, and it will benefit from the same solution. Okay. Just some stuff that is in progress. AI is obviously our current situation. Thankfully, the council panicked first with AI and ChatGPT and the likes, but then they understood what it's there to do, and we have experience with AI, so we're making progress with that. All serverless as well. And IoT is getting there, so we want to take Palmerston North to possibly the best council in New Zealand. And thank you.
Thank you, Atilio.